So I'll start from sodium sulfate. Here we have sodium. I'll start from sodium sulfate. We have sodium sulfate. So what we have to do here is that we want to calculate the oxidation state of sulfur in sodium tetrasulfate. So now what we are going to do is that we need to find the valency of sodium and oxygen. And we all know that sodium is in atomic number 11, and in the shell sodium arranged like this 281, which means sodium has to lose this 1 electron to become what? Positively charged. We have sodium like this. So what we have to do is we are interested in this one, and in case of oxygen, we know that oxygen is in atomic number 8, and the arrangement is like this 2 6, which means sodium needs 2 electrons to become what? To become in order for the shell to be what? To be stable, for the atom of oxygen to be what? To be stable. So sodium needs 2 electrons. So we add 2 to this one, it will be 8. So that 2 is what we need. So we have sodium like this, minus 2, which means sodium has to borrow 2 electrons for the atom of oxygen to be what? Oxygen needs to borrow 2 electrons for its atom to be what? To be stable. So what we have to do here is this. We have sodium as 1 charge, which means sodium has the valency of what? 1. So we multiply that 1 by this 2. We have 2 plus sulfur plus, we open the bracket, we have this oxygen. Oxygen has the valency of what? Minus 2. Don't forget we have 4A. So we have minus 2 times 4. Everything will be equal to what? 0. So we have 2 plus x plus minus 2 times 4. We have this what? Minus 8 is equal to 0. So here we have 2 plus x plus times minus, we have minus 8 is equal to 0. So here now we have 2 plus x is equal to 8. For us to get the value of x, we just do small mathematics, like x is equal to what? 8 minus 2. So we have our s to be what? 6. So the oxidation state of sulfur in sodium tetrasulfate is what? Is 6. So let me take another example. Let's say we have this example, which is what? Nitrogen oxide. So in case of this is example 2. In case of this, we are interested in what? In this, because we want to know the oxidation state of what? Nitrogen in nitrogen oxide. And from here we know that the valency of oxygen is what? Is minus 2. So this is very simple. We'll just say N plus minus 2, which is the valency of oxygen. Everything will be what? Is equal to 0. So we have plus times minus, we have minus, we have N minus 2 is equal to 0. So oxidation state of nitrogen is what? 2. So let's take another example. Let's take, we want to know the oxidation state of carbon in what? In CO2. So it's the same thing. We just have to mark carbon because we want to know the oxidation of this carbon. So we'll mark carbon like this. So we have carbon plus, we know that the valency of oxygen is what? Is minus 2. So we have minus 2, and we have the 2 here times 2. Everything will be equal to 0. So from here we have carbon plus, open bracket, minus 2 times 2, we have minus 4 is equal to 0. So we have carbon plus times minus, we have minus 4 is equal to 0. We have carbon to be equal to 4. So here the oxidation of carbon in CO2 is what? Is 4. So let me take another example. Let's say in this radical NO3 that carry negative charge. So in this one, we want to know the oxidation of nitrogen in this radical triazonitrate. So what we have to do here is this. We'll say N plus valency of this. You know the valency of oxygen is minus 2. Minus 2 times 3 is equal to, instead of to put is equal to 0, we'll say is equal to what? Minus 1, because this radical has negatively charged. So we'll now say N, we'll say N plus, open the bracket, minus 2 times 3, we have minus 6 is equal to what? Is equal to minus 1. So here we have plus times minus to be equal, plus minus is minus, Abby. So we have n minus 6 is equal to what? is equal to -1. So for us to find the value of n, we'll say n is equal to -1. If this one comes this side, it will come to what? It will turn to +6. So we have our n to be what? 5. So the oxidation state of nitrogen in triazonitrate radical is what? Is 5. So let me carry another example. Okay, in this potassium tetraoxomanganate, we have a potassium tetraoxomanganate. Yeah, we know that the potassium is in atomic number 19. Potassium is in atomic number 19. So, and it is written like this. It is written like this: 2881. So, which means potassium has to lose this one electron in order to become what? Potassium ion. In order to become potassium ion. So this is the valency that we need here, and we know that oxygen has -2 valency. So what we do here is this: we just say, okay, potassium has the valency of 1 plus manganate. Then we open the bracket. What's the valency of oxygen? Is -2, and it has 4 here, times 4. Everything must equal to what? 0. So we have 1 plus manganate, -2 times 4, we have -8 is equal to 0. So we have 1 plus manganate -8 is equal to 0. So here we have 1 plus manganate, -8 is equal to 0. So 1 plus manganate, so this -8 will come to this side, so it will become 8 instead of negative. So this crossing will have effect on the negative. So for us to get our manganate, we have 8 minus 1. So manganate is equal to 7. So oxidation state of potassium in tetraoxomanganate is what? Is 7. So let me take another example. Let's check this one. Hydrogen tetrasulfate. In this hydrogen tetrasulfate, we know that hydrogen has the valency of 1. So 1 times 2 plus X. We know that the valency of oxygen is what? Is -2. We have -2 times 4. So everything will equal to 0. So we have 2 plus X. -2 times 4. We have -8 is equal to 0. We have 2 plus S is equal to 8. So our value of S is equal to what? 8 minus 2. So S is equal to 6. Now, in naming the compound, now this A2SO4, if we were to name it, we will name this as what? Hydrogen, since it has 4 here and the previous of 4 is tetra. So we know that 1 is mono, 2 is di, 3 is tri, 4 is tetra. So this is the previous we are going to use. 4 is tetra, 5 is pent, 6 is S, 7 is ept, 7 is ept, 8 is ox, 9 is non, and 10 is dec. So it doesn't, for now, it doesn't need up to like just give just give some of the previous. So here we have hydrogen. 4 is tetra, so it will be hydrogen tetra also sulfates. Now you now put the oxidation state, so which is 6. So we write it like this. So that means the name of this compound is hydrogen tetraoxosulfate 6. So in case of this one, KMnO4 is very simple. What we are going to do is that we know that K is potassium, so we'll say potassium is potassium, and we have 4. I will know that our 4 is tetra. Potassium tetra also manganate, tetra also manganate. Then we'll now put our what? We'll now put our oxidation state, which is what? 7. We'll put our, which is 7. So this one is written as what? Potassium tetra also potassium tetra tetramanganate 7. So in case of this one, for us to write this one, so we'll just say sodium. This is sodium. We have tetra, sodium, tetra. We have tetra. We have oxygen, tetra. Also, we have sulfur there, sulfate. Sulfur is sulfate, and then we have the oxidation state to be what? We get the oxidation state to be what? To be 6. So this one is we'll put it like this. So for us to name this compound, we'll say sodium tetra also sulfate 6. In case of this one, we have NO, which is what? Nitrogen 2 oxide. So this one is nitrogen. This one is nitrogen. So we'll put our prefix, which is what? 2. Nitrogen 2 what? Oxide. Nitrogen 2 oxide. And like this one, we have CO4. What we have to do here is that we have carbon here. It's carbon. Start from carbon. Then we'll put our what? Our oxidation state, which is what? 4. Carbon 4 what? Oxide. So that is how to name